Hi, it's Tom again. In this video, we're going to take a closer look at the char data type, which is part of the integer family of data types. Before you wade into this video, you probably should have watched the Understanding Integers video, in which I went through a program that did similar things with integers, longs, shorts, and the unsigned equivalent of those three types. In this program, we're going to basically do the same kinds of things we did with the Understanding Integers program. We're going to look at the character data type, figure out what the largest and smallest values we can store in it are, and we're going to use basically the same techniques for doing that. But we're also going to really examine the difference between, you say, a char and an integer, and how we actually get the character part of it. So that's the aim of this program. So similar to the last program, I create a constant called bits per byte because I want to actually figure out how many bits a character takes up. And I have a variable for storing that calculation. I've created a variable. In this case, it's a char variable, an individual character, being very explicit with my naming there. Like the previous program, I've set it to -1 because I want to test to see if a char variable can actually hold a negative value. There's a bit of an interactive thing here. We're going to change this from char to other data types. And then, like the previous program, I have two variables to hold the minimum and maximum value that the char data type can hold. I determine the number of bits using the same, almost the same size of calculation, so bits is equal to size of. I could have used in brackets there an individual character, but I just elected to be different and just chose char there this time, and then times 8. Again, if the character variable is able to hold the -1, then this will be true. Okay, meaning that it's a signed data type. It's not so obvious whether it's signed or unsigned, actually, is it? So that will subtract 1 from the bits, which is helpful for the minimum and maximum calculations. The minimum and maximum calculations, like the previous video, what I'm doing is I'm finding out the maximum value by taking the number of bits that are used for storing the number, using that, taking a base of 2 and raising to the power of that number of bits. And then I'm shifting it by 1 to account for the fact that we start at 0. And then the minimum value, I'm also overflowing, taking maximum value, overflowing it by 1 to determine what the minimum value is. So again, similar to the previous program, I'm not bothering with the memory address this time, but I'm showing how large individual character is. I'm showing the minimum and maximum values. Now, because these are character variables, one thing that's different in this program is that I want to see the actual numbers. If I don't typecast minimum value and maximum value as numbers at this point, it's actually going to try to give me the characters that correspond to the minimum and maximum values. And that's not very useful to me right now. So I want to actually see the numbers. So that's why I'm typecasting to an integer. We're going to do more in this program. For now, I've just got to press enter to continue and cn.ignore to pause the program. We'll add code in a minute, but let's run it the way it is. So an individual character uses 8 bits of memory. It's very small and can store values between -128 to +127. So we can see that the default char type is in fact a signed data type in this version of C++. So let's try changing that. I'd like to change it from char to unsigned char. Sorry, my microphone's probably really close to my keyboard, so you probably hear me pressing my keyboard here. I apologize for that. So I've changed those all to unsigned, and let's see if that actually makes a difference. So I'll go ahead and run it. And we can see, yep, there is such a thing as an unsigned char, and it's just shifted it, so now it's 0 to 255. So that kind of makes sense. All right. So for the next stage of the program, what I'd like to explore is basically let's deal with how characters actually end up displaying characters. So we know that what is actually stored in memory is a small integer number. Each one of those integer numbers corresponds to a character in a character set. Now, depending on what you are using for your character set, the character codes might be different. So it might be ASCII code or ANSI code, or EBCDIC is another one, an old school one. Unicode is a newer one. So it really just depends on your system and your compiler, etc., and so on. Although there is some commonality between Unicode and ASCII and ANSI code sets in terms of the first 127, I want to say, but I'm not 100% sure of that number. But there is some interoperability in the low end. So what we're going to do is we're going to write a little loop that's going to go through from the minimum character to the maximum character, show me the character, show me the code, both in as a decimal number as well as a hexadecimal number. So I'm going to start off with just some column headings. So I'm going to tell the user I'm displaying some characters using a loop. I want the first column to be char, then decimal, then hex, and I've kind of spaced it out the way that my plan dictated. All right, and now I'm going to do a for loop to go from the minimum value to the maximum value. So at this point in our studies, we haven't done any looping or anything along those lines, but I imagine most of you will recognize the for loop from your C# studies or your intro studies. So it's a for loop. I have a counter called counter, not feeling very creative. I'm starting that counter off at minimum value. I'm going to continue to loop while the counter is less than or equal to the maximum value, and then each time I'm going to increment the counter by 1. In the body of the loop, I want to output the counter a number of different ways. Now, in order to do some formatting, what I've had to include is a library called IO_manip, input-output manipulators. These are various different identifiers and such that allow us to do formatted output. So I'll explain the ones that I use. The first one I'm using is setW, which is short for set width. It basically means that the next output that happens that I send to cout is going to fit into a minimum of 4 characters. Okay, so if my counter, for example, holds the value 0, or let's say it holds the value 12, so that will actually output the counter. Well, it's outputting it as a character in this example, but if it was outputting it as a regular number, it would be space, space, 1, 2. So a minimum field width of 4. So I'm saying in a minimum field width of 4, output the character. Okay, so a character will only be one character, so it would always be space, 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 character. And then in a field width of 8, these are essentially my column widths. I want to output the counter again, but I'm prefacing it with the word dec. What dec means is that I want it displayed as a decimal number. That's what it is by default. So actually, technically, if I left this off, I probably wouldn't notice any difference that first time through. The second time through, though, I would notice a difference, because you'll notice in my third column, I'm using the word hex. What hex is doing is it's actually going to be displaying the counter as a hexadecimal number. And the problem is, if I changed it to hex and then went back up to the top of the loop, it would stay hex until I changed it back to decimal or dec. So that's why I have them both there. So in summary, I have a column with the counter typecast as a character, a column with the counter in a decimal number format and a base 10 number, and then another column with the counter shown as a hexadecimal number. So let's go ahead and run that, and we'll see how we do. Okay, so I'm still using the unsigned character 0 to 255. Press any key to continue. It scrolls away for all 255. I'll scroll back up to the top here. So the character code 0, oh, my hex column is not looking very good. I have to adjust that heading a little bit. But at any rate, I don't see a character for the ASCII code 0 because that's the null character, so it's not printing. You'll notice too, I'm getting some kind of weird symbols. These are characters that can't be output using how I have my computer set up. So you'll notice a lot of these. I get a lot of those for the first bunch. Starting at 32, which also appears to be blank, that's actually the space. So decimal 32 or hexadecimal 20 is effectively what the character code for space is. Got a bunch of punctuation, followed by my 0 through 9 characters, a bit more punctuation. Then we get into, at 65, we get into the uppercase letters. A little bit of braces and brackets and punctuation in between. Then we get our lowercase letters, A through Z, and so forth. Special characters tend to be higher up based on an unsigned char. What I'm going to do is I'm going to go back into the program. We're going to run this one more time, but I'm going to change it back from unsigned char to just a regular char. We'll see if there's any difference. And interestingly enough, there's not much difference. Just obviously not obviously, but the order in which these characters happen are a little bit different. So some of those special characters that were happening beyond 127 are now coming up as negative numbers, but they're the same characters in the same order. And then, 0, we start getting into the same characters we had before. Okay, so that's how characters are stored. And that's basically the video. Thank you very much.